Welcome to another ELS tutorial video. In this video, we will walk through the main process of using ELS to model and analyze the progressive collapse of an example building due to the failure of a primary structural element. We will cover various aspects of the process, including creating a model, specifying reinforcement details, and applying pre-processing actions in the ELS modeler. We will then run the analysis and examine the simulation in the ELS results viewer. Our model consists of a reinforced concrete building with the following specifications. Live load assigned is 50 psf. We'll apply an example code requirement in the problem to see how code specifications can be implemented in ELS. The adjusted load we will be applying will be subject to the formula 1.2 multiplied by the dead load plus 0.5 multiplied by the live load. Reinforcement details are as follows. The girders are divided into 3 equal spans with 2 typical sections. When we first launch ELS, we will be met with this window asking for the basic project properties. We will specify the level height as 15 feet and click OK. We'll specify the unit by visiting the Tools ribbon tab and choosing Units. We'll specify inches for length and kips for mass. We can adjust the grid spacing from the Drafting Settings dialog under the Draw tab. Let's set the spacing to 1 foot to aid with modeling. Next, we'll specify the column style properties from the Styles browser. Double-click Column Style 1, click on Geometry, specify width and depth as 18 inches by 18 inches, with normal concrete as the material. We will specify a 2-inch cover, 3 bars of number 8 area in the 2-2 direction and 1 bar in the 3-3 direction. There will be 3 stirrup branches in each direction, spaced at 8 inches on center with number 3 area. To insert the column, we'll use the column command from the Home tab and switch the view to the top view. To define the element mesh of the column, let's navigate to the Properties browser with the column selected, scroll down to General Mesh Specifications, and define the column meshing as 10 by 1 by 1 for now. Now, we'll right-click and copy the column. We'll click the center of the column face to specify it as the anchor point. Specify the insertion point as 360 and 0 in the command line to insert it at 30 feet to the right of this column. If the command line is not visible by default, we can activate it from the View tab. Now, let's create 2 girder styles for the 2 typical girder sections. Let's double-click Girder Style 1. Specify the geometry as 12 inches by 30 inches with a material of normal concrete. For reinforcement, we'll specify 4 number 10 bars at the bottom, 4 number 4 bars at the top, and 1 number 3 sidebar. For stirrups, we'll specify 2 stirrups in each direction, at a spacing of 6 inches, since these stirrups are the ones near the connection. Let's create Girder Style 2. We can create a new geometry style, or we can just choose Girder Geometry 1, since the 2 girder styles differ only in their reinforcement details. We'll specify 4 number 10 bottom bars, 2 number 4 top bars, 1 number 3 side bar, and normal steel for the material. For stirrups, we'll specify 2 number 3 branches in each direction, with a spacing of 12 inches on center. To draw the two end spans of the girder, we'll need a guide point at 90 inches away from the face of the column to snap to. So we'll draw a draft line starting from the face of the column at the midpoint, then specify at 90 and 0 for the endpoint. We'll do the same for the other column, but we'll specify -90 and 0 for the endpoint of the draft line. Now that we have our guidelines, we'll draw two girders alongside these lines. Let's click the girder command from the Draw tab or the Home tab, then click the start and end point of the draft line to draw a girder alongside it. We'll repeat the process for the line at the other end. So far, we've used girder style 1, which is selected by default as the style to draw the end spans. Let's change the default style to girder style 2 to draw the intermediate span of the girder. To allow for continuity of the reinforcement bars while not allowing for duplicate spring generation, we'll enable the extension of the reinforcement bars in one direction only at the interface. Let's head to the Properties browser, specify the extension of the girder 2 bars as a positive value of 1 inch, and the extension of girder 1 as a negative value of 1 inch. This means that the extension of the reinforcement bars is allowed in one direction only at the interface, so springs are generated, but duplicate springs are avoided. In examining the girder reinforcement extension into the column, we can see that the reinforcement is extended past the midpoint of the column. If we allowed this for girders on both sides of the column, the springs generated between the elements at the center would also be duplicated. Hence, we will instead set the extension of the reinforcement bars at the start of the girder to 9 inches only. For the other end span, we'll set the start reinforcement extension to span the whole width of the column, or 18 inches. Now that we have our frame building block, we can start replicating it in the X and Y directions in the next video.